Hello everyone, my name is Shi Phúc Pham and today I will present about the paper title is Improving Acute Spatial Pyramid Modeling in DeepLabv3+ plus using the attention mechanism for the diversity of polyps. Our titles, our authors like this. Uh, we are from Department of AI Convergence, Jeonnam National University. My supervisor is Professor Hưng Jung. About the content of this paper, first we will introduce about the polyps, and the second we will talk about the related studies with my papers, and the third we present about the proposed method and the experiment result. And the last, we talk about the summarization, the conclusion of this presentation. Let's start with introduction. About the polyps. A polyp is a small clump of cells that forms on the lining of the colon. As we can see in the figure on the right of the slide, the most polyps are harmless. Over the time, polyps can develop into cancer, which may be fatal when found in its later stage. About the polyp segmentation, to develop the algorithms for segmenting polyps in image taken from endoscopies to achieve high segmentation metrics in the dataset. The evaluation metrics I use in this paper is the Jacob, the precision, and the recall. About the related was related with my paper, I will present about 3 papers has conducted in 2020. The first paper has a title is Real-Time Polyp Segmentation Using Unit with IOU Loss. This paper presents about the unit with IOU loss. The author added augmentation about 2 methods in augmentation. It are random rotations and random horizontal flips. The second paper related with my paper is the paper depth-wise separable acute convolutional for polyps segmentation in gastrointestinal tract. The author in this paper using ResUnit++ architecture and pyramid pooling was used as a bridge between encoder and decoder of ResUnit plus. The last paper I will talk is the assemble unit model for efficient Polyps segmentation. This paper using unit model with two different encoder checkpoints, ResNet 34 and EfficientNet P2. About the proposed method. The proposed method based on the DeepLabv3+ architecture and attention mechanism. As we can see, this model has two paths, encoder path and decoder path. In the encoder path, we use pre-chain ResNet. After that, the future injection by ResNet put into the actual spatial pyramid pooling and through the attention layer for each layer in ASPP model. After that, we concatenate the output from the X layer of ASPP model. Then we got output in the encoder path. In the decoder path, we use the feature from one by one convolution layer in ResNet and concatenate with the output in the encoder. Then we got the prediction mask like this. The input mask, the input image were ejected feature by ResNet architecture has described like this. And the attention in the encoder path has described in this function. We use the attention mechanism to improve the diversity of the polyps in the image. About the dataset, we use the dataset in medical challenge. It is from the endoscopy, the endoscopic image of the colon labeled by the expert. And this is the 2D image with JPEG format. And the size of the image have real size from 332 by 487 to 1920 by 1072. The number of image in this dataset is 1360 images with ROI. About the experiment result, we do the experiment with 6 models like this. The first model is UNet. The second model is REST UNet. The third model in this paper and the UNet with the pre-trained of MobileNet v2 and the DeepLabv3+ with pre-trained RESTnet and the proposed method. Our research get best results from the other models. And this is an example about the results from the other models and the proposed method. The conclusion of this study, we presented an approach for segmentation with 2D image based on DeepLabv3+ and attention mechanism. The results demonstrate our proposal outperform other models always used in the medical area like UNet. We also tried cross-attention mechanism, but the performance was not better than the proposed model. In the future, we plan to do experiments with the reconstruction image in the encoder path to improve the performance of the model.